operations staff working together in harmonious glee seems to avoid the fact that if we as security professionals can't automate 98% of our security infrastructure, how are they doing it? Okay, it's I think ultimately it's a squeezing of the balloon problem, right? They think they're going to fix everything in the application, ignoring the transport, because in public cloud, that's pretty much all you can do. But if we're in a hybrid model and we're not in public cloud environments, I have to secure my enterprise. What is this new model of developer operations going to do to us? And I think that's fascinating. So you can either go to lunch or I got 8 more minutes. All right. So what's interesting here is we bubble up. This was an interesting thing about failure and owning failures. So there's a company called Bitbucket. They ran a storage repository on Amazon, and they were down for like 20 hours or so. And there was this big complaint and brouhaha back and forth. And it's very interesting because when they wrote up their summary, they said, "Look, we were attacked. It was giant. It was basically a big, massively scaled DDoS." And this was the customer. And what it was, so after 16 or 17 hours, Amazon was able to figure out, in conjunction with the customer, that they were under attack, UDP floods. What was interesting about that was, that it took that long, and people are saying, well, shouldn't Amazon have detected a DDoS? Shouldn't they? Well, I don't know. How do they know what's good or bad traffic? How do they know that wasn't, another Animoto gigantic, successful marketing effort? They don't look at the traffic. And moreover, the customer couldn't see it because once it hits the security groups and basically IP tables in the kernel, it just gets dumped. So they didn't see it was being flooded, so resource starvation, DDoS. So that's kind of the customer's perspective. What was interesting about that is, when I look at this, and I say, if you are silly enough to single source all of your infrastructure, no matter how resilient, to a single provider, you're going to get your ass handed to you on a plate. And what was very interesting was, from Amazon's perspective, they rightfully came back and said, hey, you used a single instance in a single availability zone in a single region. Why didn't you take advantage of the high availability functionality and put another, so who owns this failure, right? Is it a mixture of both? Should Amazon have detected the DDoS? Should the customer be more, aware of the pros and cons of using cloud? Should they have redesigned their application? Should they have taken advantage of the cloud platform? It's a little bit of both, right? And we see this more and more. We've seen, for example, people's concern about Amazon's response to things like this mass-scale SIP attacks, where bots were launching targeted attacks in DDoS floods against SIP-enabled end nodes on the internet. They basically said, well, we don't know if it's good or bad, so we generally we take your report and we try to get the two parties to talk. Well, if that's a botnet, good luck with that, right? You're not going to be able to get them to talk, but they're in a delicate balance of trying to maximize availability and not shut people out. So Benjamin Black said, marketing is not a root cause. So if you believe what you read without understanding the implications on your architecture, that's going to be bad. So cloud does not obviate your need for application security. It doesn't help you with things like information exfiltration, data leakage. For example, with Amazon as a good example, there's no outbound filtering. So unless you have something on the host, right, even those inbound ACLs, non-stateful, there is zero outbound ACLs in those security groups. So if you get owned at an application layer, then I can take that information if I have no protections on the end node itself and just start shipping off data anywhere I like, right? So this notion of how I would then protect and where I invest means I have to put more stuff on the host. I talked about this for the last couple of years. It's become more popular now to talk about mainstream-wise, but the cloud being used as a giant botnet happening, right? That's all I really need to say about it. This notion I coined a tricky little term called EDOS, which is economic denial of sustainability, which is essentially, for lack of a better description, a variation on click fraud, where I essentially use the scalability of cloud to do bad things, drive up the usage of compute, network, and storage for which you as a customer are ultimately billed. And then you get no money out of the backside of it. So your bill ends up being $100 grand and you sell $10 worth of stuff. I put you out of business, right? Interesting notions here that are starting to be use cases for security in cloud, just a couple of them. But what's interesting is we still have all this crap, right? The OWASP top 10, still there, still affects a ton of folks in cloud. Mostly because we do a poor job of application security. But what that also means is there's kind of the pros and cons, right? The reality is that in certain cloud services, there's amount of goodness you can spread in a very quick time. Alex referenced this yesterday, where I can roll out a fix, a change, a new piece of functionality to millions of users very, very quickly. right? Which is good. I can also do that where it becomes very, very bad. Here was a great illustration buried like 7 conversations down in the support forum that said, by the way, in 2 weeks, we're changing the policy in Google. And what that policy was anything that you happen to, if it was private in a group or discussion that you link to externally, that we crawl, is now public. So people would click that little cool thing in Google Voice that said share their voicemail transcriptions, and you could then do a Google search and start reading and listening to people's voicemails because they weren't understanding. It's like Facebook, right? You got to have a freaking PhD to understand what the privacy settings actually mean. But better yet, they can roll these changes, and you don't necessarily know what it impacts. So there's good and bad associated with that. And how we understand, depending upon the level of service, what one of these policy changes means to us is pretty critical. Also, this is pretty interesting to me, and I haven't updated the slide, but I use Twitter as an example. There's a lot of Web 2.x apps that were painted when they came out as being cloud that had no cloud essential characteristics whatsoever. They were built on monolithic stacks, running at a colo provider, just like every other app in the world. And this was when Twitter was getting flooded. We came to find out that Barrett actually came to find out that they were basically, externally load balanced to what ends up being a single source provider. Now they've changed things, but interestingly, what we found is that you're not supposed to have this sort of overcapacity issue in cloud. It's another expectation, the illusion of infinite scale. The reality is depends on how you provision your apps and what your cloud provider is like and whether you've architected this way. And in fact, they just announced that they're going to build their own data center. So they're moving away from hosting a colocation provider. They'll leave some stuff on AWS, but to handle capacity and better control and better security, they're building their own data center, which is the antithesis of cloud if you look at how it's marketed. Like, why wouldn't you just put everything in AWS? Well, again, not all clouds are built equal. Now, I'll use another extreme, which is kind of a good example, which is Heroku. Anybody heard of Heroku? They allow you to do Ruby on Rails deployment really easily, right? So their architecture is really slick. Here's all the layers. You got a but you've got all of this abstraction, which actually, strangely enough, sits atop even more abstraction. What do I mean by that? I mean that Heroku actually runs on AWS. So here's the layers. You've got Nginx, you've got Varnish as a cache, you've got Erlang as a routing mesh, you have their Dino grids using Debian Linux, and then you've got PostgreSQL, Memcached, and a whole bunch of stuff. So these are multiple tiers, multiple layers of incredibly complex capability to allow somebody to bring up IRB, push to Git, and deploy an app, right? Really easy. All that single button push IDE functionality, all of that is sitting upon all of that. So what's interesting about that is that's a fantastic example of using cloud and application architecture. Could you imagine trying to troubleshoot where something broke in a stack like that? As an AWS person or a customer of Heroku or Heroku themselves, really, really interesting discussions about, again, ownership, troubleshooting, and transparency. So this isn't all about new stuff. This is about being pragmatic and practical about how things ultimately get operated. And what's missing is a lot of the threat modeling and risk assessment and pure common sense management. We get so wrapped up in trying to, say cloud, we don't necessarily understand what's different or what's the same. And if we look at these, most of these problems are exactly the same sets of problems we've been having for a long time. The providers still have them. They focus on maximizing, in many cases, availability, but much of this is out of your control. The reality is, in the last couple minutes here, you're at the mercy of what your cloud provider gives you in terms of security capabilities, or you're going to be implementing, if it's infrastructure as a service, you're going to be implementing a lot more stuff in the host. There's all sorts of interesting technologies that are looking to fix problems in a way that I think are being responded to quicker than they ever have before. In infrastructure, we're seeing some of these converged compute, network, and storage solutions, and even though I implied that they are complex and more difficult, they also give me a single pane for management and policy enforcement. A lot of the virtualization platforms are evolving. Next generation IP networks, which give more visibility and media aware capability to these networks, which is good for some things, bad for things like privacy. So at the infrastructure layer, we're churning and we're getting answers, and we're having folks look at how they need to manage infrastructure differently. At the metastructure layer, we're seeing things like DNSSEC, extensions to BGP, IPv6, new protocols to separate things like location from resource. like Lisp and HIP, open APIs and interfaces. Infrastructure is still a frickin' nightmare. You know, we still have buffer overflows. We still are struggling with basic capabilities at the application layer. And ultimately, this can be seen as good, but also bad. This layer is completely disconnected from Metastructure and infrastructure, and I mean in every way. Not in ways like Alex talked about yesterday with messaging buses, where you can actually get good telemetry. It's just, you know, applications are built to ultimately today be completely invisible to infrastructure and vice versa. And what that means is, since we don't do a good job of instrumentation,